Hello and welcome everybody to Advent of Code 2023, day 13. So the eagle-eyed among you, if you've been following along with me as I've been releasing these, will notice that there hasn't been a video in a couple of days. And in fact, this day 13 video is being released on day 14. So day 12 I found really hard. I've only have 1 star for it still as of recording this. So I moved on to day 13, hoping I could just knock that one out. And that took me nearly all day to finish. And then just with being busy, I didn't get to release a video for it. So I have it done. I got it done on the day. I just haven't released a video. So this is this video today. So we're going to do this today. We're going to then attempt day 14, hopefully make that video, all going well, and maybe get all the way back around to day 12. A lot of ifs there, but yeah, so far these last 2 problems have been a big step up in difficulty, I think. And yeah, I'm kind of surprised at this early stage that I've managed to miss a puzzle day already. But yeah, that's where we are. So we're gonna go through this now, and we're gonna talk about it a little bit. I'm not going to go too deeply into my code because it's not very good code. It was really messy to write and kind of mess with my head. But I'll talk through the general solution that I came up with, and yeah, and we'll look at a little bit of the code as well. Okay, so let's jump in. Day 13, point of incidence. So from the springs in the last one, we found a spring that launches up to Lava Island. The only problem, we don't see any lava. So we're walking along this valley, and we notice that it's lined with all these large mirrors. And that some of the mirrors, though, appear to have like fallen down and stuff. So there's like these pattern of reflections that are sort of odd reflections that you're seeing. And that pattern is our puzzle input. So you see it here. We've got these sort of individual patterns separated by a blank line, where we've got dots and we've got hashes. So basically we want to try and analyze this pattern so that we can figure out where all the mirrors are. For whatever reason, so we have a safer path through it. So there's a couple of things in this that where it gets a little bit tricky. You have to sort of so I feel like the examples for this don't cover like all the cases really. So you sort of have to infer. But anyway, we'll start just by defining what is the reflection, basically. So to find a reflection, you basically need to find 2 adjacent lines that have the same pattern, either vertically or horizontally. When you find that, you need to check, the outside of each one, and keep going. And you have to see from that middle point as you move outwards, do all the lines match until you get to one of the edges. So if that happens, that's what they've defined as a perfect reflection. Yeah, so that's basically it. And it can happen either horizontally or vertically. So here we've got a horizontal one. The second option here is a horizontal one. And then up here we have a vertical one that goes out the way. And then, yeah, in the example, he highlights where they are, here and here. So basically you have to run some algorithm that finds this point for each one of your patterns. And then if it matches, if it's a vertical one, you need to know what the index to the left is of that, or so how many lines to the left it is. And then if it's a horizontal one, you need to find how many lines from the top it is. And then at the end, the formula he gives you is he wants it to be all the lefts summed up plus all the tops summed up times 100, and that gives you your final answer. So yeah, that's it. And on the surface it's pretty simple. Like conceptually it's not too difficult. If you understand the reflection logic, that makes sense. It's a little bit tricky, a little bit fiddly to find the reflections, but then there's also some other cases that you have to consider. So if you have 2 lines that match, but they like, you can have 2 lines that match that are like an individual reflection inside the thing, but that doesn't count as a reflection, because it has to completely extend to go off of one end or the other for it to count as a reflection. So that's another little edge case that you need to consider. And then the other thing, which I think I wasted time doing, is that I don't think you can have both a vertical and a horizontal in it. I think you can only have one of them. Yeah, anyway, let's have a look at the code and see how I did it. So for part 1, so I was able to do this in just one big loop that goes through all the data, each line just once, which is pretty cool. So what I do is I set up some data structures that I'm going to use, do a file read loop. So I'm going to just ignore this one, the blank line case. So if you look at our input, we know that we've got a gap between each one. So what I've done is essentially I process this input, then in the gap I do all the work to figure out the patterns, and then I generate my answers in the gaps. So do the parsing in one part of the loop, and then when I encounter a blank space, I do the rest of the parsing, or I do the rest of the processing. So this is the first part. This is just parsing out the array. So what I'm doing is I'm creating 2 new arrays, one that has a representation of all of the y's, and one that gives you a representation of all the x's. So basically it slices the grid into 2 arrays, one that represents all of this and one that represents all of these, so that I can compare them. So that's all this does. It just does this some logic in here. I also change hashes to 1s and the others to 0s, because I was using like a binary number comparison here. So if you look at this, if you can change it to 1s and 0s, each line becomes a binary number, which if you then cast to an integer, it just, if you're visually debugging, then if you're looking at lists of integers doing comparisons, it's a bit easier than looking at lists of binary numbers. So yeah, we processed all this, and now we end up back in our main loop. So up here, I created a data structure so this is for each grid basically that's in our input. I'm creating its own ID'd data structure. I store the top and I store the left, and then I actually store my x's and my y columns beside them, so that I can debug for reproducing later. This is where I convert those binaries into integer numbers. And then, so this is where the brains really kick in. This is where you have to, this is where I'm parsing either all the lefts or all the verticals. So the way this happens is I loop through each of my now integer number represents each column or each row. So this one does all of the rows. So with this, if I get an equality, so as in if I find effectively 2 rows that have the same matching value, I stop there. And at this point, I figure out what is the left and the right of that. So in this case, it's the above and the below, and make 2 sub arrays of that. So one of these arrays will be longer than the other. And if we're in a successful case, the smaller array, every element in the smaller array will also appear in order in the bigger array. So that's basically like if it's folded over, you'll have this array and this array, and they should overlap. There might be some remainders, but that doesn't really matter. If that overlaps completely, and the small array, if you were to say subtract the 2, the small array would completely disappear. That's the right answer, basically, or that means that it meets this perfect reflection criteria. So I'm basically generating these small and big array, and then I do a loop here to loop through and check them off. And then if that is deemed to be a mirror pattern, I will store that value. So I'm actually this little bit here where I do this thing and then this like counts.max thing. I actually don't know if I have to do that. So there was a case that I was considering as I went through my input that maybe there was 2 valid reflections could be in the same file. In the same grid. I actually don't think that's the case now. So some of this could be simplified, but this was while debugging madness. I ended up adding this bit of code. But in any case, that is ultimately what it does. It determines, so it stops each time it finds 2 lines that are the same. It does this comparison check where it expands outward, or where it's basically checks the above and the below to see do they get this match condition met. If they do, that's going to be our answer. So we do that twice. We do it for the top and we do it for the left. An inefficiency in mine, I do both checks, but all the time. I don't know if it is the case. Like, I think it is where only ever one of them will be true. So you could actually skip the second one if you've matched the top one. Anyway, sorry. Is what it is. I'm not changing the code now. So yeah, that's kind of it really for this. We once we figured those out, we store them in that data structure. So we store our lefts and our top values, or zeros if we didn't find anything for them. Excuse me. And then yeah, down here we just we're just resetting some of those data structures, incrementing some IDs, and we'll move on to the next grid. And yeah, that's it really. That's it for the processing. So once we have the data structure, we have all of our lefts and all of our tops. Down here, this is basically just visualization code that I'm writing, which you'll see now when I run it. This was quite important for me when I was debugging this problem because it was just so much easier to see the visualizations. And because there was only 100 different grids, you could quite easily, put a read line in here and hit enter between each one to slowly examine each one and see where you were making mistakes if you had issues, which I did have to do a bit. So that really helped. And then the final line to give us our answer, just pull out all those lefts, add them together, pull out all the tops, add them together, multiply that by 100 and sum the 2 things. And that gives us our answer. So with that said, let's run 13.1 on our sample. And there we go. So there's our printouts. So you can see our dividing lines here, these in red and the dividing lines in green. So we've got a left 5, top 4, and that gives us 405 based on that formula. And then if I run this for the input, it'll go brrr, and this it doesn't actually take this long to run, but I have there's a sleep thing in here which just pauses how quickly the screen gets refreshed in my visualization code. So there's an artificial pause in there. It actually only takes a few milliseconds to run this whole thing. And yeah, you can see here's all of our divisions. And as I scroll through this, I only see that there's one valid one per each one. So I think that's pretty true. And yeah, that was my answer for it. So that works. Yeah, so that is basically the bones of the whole solution. So I'm going to just flash up the part for part 2. Well, we'll talk about part 2 first, sorry. So what they say for part 2. Now, part 2 is a little bit complicated to understand. I think some people misinterpreted what it was. But basically what they say is that in the grid, there's exactly one smudge on a mirror that if you clean it, or if you, so you change its value basically, it'll cause a different valid reflection line in your input. So the most naive solution for this, and this is what I did because my brain was so broken, you go through every single cell and you flip each one. So flip each bit of your input and run the process on each new grid that's generated by flipping just exactly one bit at a time. And you will arrive at your answer if you do that, basically. The main part. There's only one little thing that you have to make sure you do, or else you'll tie yourself up in knots a bit. And the key line word that he says is, where is it? It's in the input here. So it's what they say is this has been the advent of reading comprehension, which is genuinely going to be tricky in these problems if you're not a native speaker in a lot of cases. And even for us fully native speakers, these problems sometimes are like reading a different language. So I don't blame anyone for misreading something in a problem. So this thing up here, there's one, you need to locate and fix a smudge that causes a different reflection to appear. There's the old reflection lines won't necessarily continue being valid once the smudge is fixed. Effectively, what it's telling you is ignore all the old ones. Just ignore the old ones. So if you fix a smudge somewhere and it creates a new reflection, even if the old reflection was still valid, just ignore it. You don't have to do anything with it. That's the key. And also there will only be one new valid reflection per file or per grid. And what else? Yeah, that's it. So, and it could be either a vertical or a horizontal. It doesn't have to match the same as it was the last time. So with that in mind, let's just glance briefly at the code. So same basic structure, except inside here, I have this. So I do once with the original input. So I get my original top here and an original left, which are useful later on. Then I go into this big loop of basically loops through every single character. We flip a value if it exists. So if this was a 20 by 20 grid, we'll be doing this 400 times, and each time exactly one of the characters would be flipped from what it was in the original. We do the exact same code, run the exact same process, except the only little trick here is, so my code here for are there multiple matches per grid now actually does need to be done, because previously it didn't need to be done because you couldn't get multiple matches. Now you can definitely get multiple matches. So you need to add an extra condition in here that says, and the value that we find doesn't equal the original value, because we know we need to ignore that now. So if we ignore that, we'll get basically just the new values. So we run this. I'm running this like, so to run, say, the example I used earlier, 400 times per each grid. If it was 20 by 20 grid, we'll get a whole bunch of lefts and a whole bunch of tops that we generate. And we're going to take so there should just be one unique value in the end of this when we compact it all together, which is what we do here. We end up with a left and a top. We store those two values in these arrays, and then in the similar data structure, I moved it around. I'm not doing the visualizations in this one just because it's, I thought it would just be too much overhead, and I didn't want to break my brain working at all the different cases. And yeah, that's it really. So we do our lefts and our tops, and then at the end we apply the same formula, and it's pretty fast. So brute forcing it is pretty fast. I think maybe he was sort of thinking about this pattern recognition stuff. It's not going to be the size of the inputs that's going to cause the issue. It's just going to be the parsing logic and stuff like that, which I think if that was his thought, it's right. So run this on the sample, runs in a few milliseconds. That's the right answer. And then for the input, that is the right answer, less than a second, and it is the right answer. So there we have it. I'm going to end this now because I don't want to talk about day 13 anymore. So I'm going to go off now and have a look at day 14, see if I can figure that one out. Maybe I'll come back to you today with another video. I can't imagine that. But it might happen. And then maybe with all the luck in the world, I'll come back to you even later on today with a day 12 video. Who knows? Anyway, thanks for watching, folks. And I will hopefully see you later on. And if not, hopefully I'll see you tomorrow. We're just going to keep going at this stage. We're going to release videos as we solve puzzles, and we're going to try our very best to keep up to date. If we can't solve a day fully, we're going to skip that day's video, and maybe come back to it. So anyway, that's it for now. And yeah, we're going to keep going. This has been a challenging year, and I'm looking forward to keeping going with it, even though it is struggling, is causing me a lot of strife, and it's breaking my brain a little bit. So, see you later, guys.